15 when we're done. Okay, so we have simplified trig expressions and equations. We have proved the identities. Now we're going to actually solve them. So it says a trigonometric equation can have several solutions, so we can have more than one, depending on the defined interval. So we have these little intervals here that we're defined on. So to solve it, you must isolate the trigonometric functions. That means basically like when you're trying to get x by itself. We're trying to get the little trig functions by themselves first, and then we're going to watch for extraneous solutions, meaning sometimes you may think there are more there than are really there. Okay, I left my notes back here. All right. Oh, that's still not it. All right, so let's look at number 1. We are trying to solve for theta. So the first thing we have to do is get sine theta by itself. Okay, you do it doing the exact same type of solving that you do always and ever. Trying to get this by itself, what would be the first thing that we do? Add 3 to both sides. So that gives us 6 times the sine of theta equals 3. Then I'm going to do what? Divide by 6. So I get sine theta equals 3 divided by 6 is 1/2. So now that I have isolated the trig function, how do I get theta by itself?
You do the inverse.
Do the inverse. So theta is equal to the sine inverse of 1/2. Okay. Now, this interval here is important. Okay, we're going from 0 to 2 pi. So a whole circle is what we want. Sine, I want the sine inverse of 1/2, and it's positive. Sine is positive in which quadrants? First and second. So it's just these 2 quadrants that I want. What is the sine inverse of 1/2? Pi 6, right? And pi 6 is in the first, that is my first quadrant angle. And so then I also need my second quadrant pi 6th angle. And what's that? 5 pi 6th. And so these are your 2 answers. Okay. Everybody good with all that so far? All right, so let's look at, wait. What? Because we want all of the answers from 0 to 2 pi where sine is 1/2. Does that make sense? So we know sine is positive in the first and second quadrant. Good question. Anything else before we move on? All right, let's look at number 2. I want to get cosine by itself, so what am I going to do? Subtract 5. So get -1 equals cosine theta. Doesn't really get much easier than that. So theta is equal to the cosine inverse of -1. I'm going from 0 to pi, so just from here to here, right? This is negative. Is cosine negative in either one of those quadrants? Yes. Which one? In the second quadrant. So I need my second quadrant. So it'll be second quadrant-ish. This is actually a quadrantal angle. But so what's the cosine inverse of -1? Pi. So theta is just equal to pi. Well, remember no, it's all students take calculus, right? And so sine is what's positive in the second quadrant. Since that cosine inverse is a -1, I wanted the quadrants where cosine would be negative.
Cosine's always an opposite.
Does that make sense? Yeah. All right, we good? What?
Cosine is the top 2, and sine is the quadrant 1.
When you're straight up taking the inverse, yes, but this is a little past just taking the inverse of it, because just the plain old sine inverse of 1/2 is pi 6, right? But I want every angle from 0 to 2 pi that would give me the sine of 1/2. That's why I add this one in here too. Does that make sense? So that's how you get it, and then you use it from there. So help. Yes. Yeah. Okay. We good? All right. Let's look at number 3. We've got -2 tangent theta equals 2 square root of 3. So what would I do to get tangent theta by itself? Divide by -2. Good. So this is going to give me tangent theta equals what? Negative square root of 3. That means that theta is equal to the tangent inverse of negative square root of 3. So my interval here, I'm going from pi to 2 pi, so it's these 2 quadrants. Is tangent negative in either one of those quadrants? The fourth, because it's all students take calculus, so it's in the fourth quadrant. Now, let's say tangent wasn't negative in any of those, then my answer would just be no solution. Okay, that is possible. So that means, first of all, just think, what is the tangent inverse of the square root of 3? Close, it's pi thirds. Yeah, so it's the tangent inverse of the square root of 3 is pi thirds. So I want my pi thirds fourth quadrant angle, and what's that? Okay, so here's how we do this. To get to 2 pi, that would be 6 pi thirds, right? And then I back up 1, so it's 5 pi thirds. Yeah. You went in the wrong direction. All right, everybody good with all that? Now, we're treating these little, yes? Sure. You're going to miss all the important stuff I'm going to say, but go ahead. You're going to treat the cosine thetas or all the little trig functions just like variables until the very end. So you can pretend like this is 5x plus the square root of 2 equals 3x, right? And you handle them the exact same way. So I'd want to get all my variables on the same side, right? So I'll want to subtract 3 cosine theta from both sides. But if I do that, what ends up over here? 0. So I'm going to subtract this from both sides, and that'll give me 2 cosine theta plus the square root of 2 equals 0. Don't ever forget to, put that 0 there. Don't lose your equal sign. Then I want to move the square root of 2 over here, so I get 2 cosine theta equals what? Negative square root of 2. Then what do? Divide. So cosine theta equals negative square root of 2 over 2. So theta is the cosine inverse of the negative square root of 2 over 2. I'm going from 0 to 3 pi halves, which is right there. My circle looks very bad, but you get the idea. And cosine is negative where in what I'm looking for? Which quadrants? Third. It is negative in the third. And where else? Second. So I need my second and third quadrant angles. So what's the cosine inverse just of the square root of 2 over 2? Pi fourths. So pi fourths, but I don't actually want pi fourths, right? But I need my second quadrant pi fourths angle. What's that? 3 pi fourths. And then my third quadrant, which is 5 pi fourths. Okay. Everybody good with all that? Easy enough? Okay, good deal. So let's look at number 5. Sine theta equals 2 minus sine theta. So do the sine thetas just cancel out? No. Okay, this is negative, so I'm going to add it to both sides, right? So I'm going to get 2 sine theta equals what? 2. Divide by 2. So sine theta is equal to 1. So theta equals the sine inverse of 1. I'm going from 0 to 2 pi. That's the whole circle, right? What is the sine inverse of 1? Now, when is sine 1? And is sine your x or your y? Your y. Pi halves. Very good. So theta would be equal to pi halves. Okay. I'm going to give you a minute. I want you to work on number 6. Come on in, you're missing all the fun. All right, so I'm going to subtract tangent theta from both sides. It's going to give me 2 tangent theta equals 2. And then I get that tangent theta equals 1. So theta is the tangent inverse of 1. And I saw most of you got to that part, and then you were kind of just hanging out there for a minute. Okay, so we are looking from, this is the interval. So the way I know how to draw my little circle thing is from this, right? And so then to know which quadrants I actually want, this is positive. I need these quadrants when tangent is positive. So all students take calculus. This is positive, tangent's negative here, so I only care about the third quadrant. Does that help? Okay, so tangent inverse of 1 is pi fourths, right? But I want my pi fourths angle in the third quadrant, and what is that? 5 pi fourths. Okay. Does that help? Is that good? Make sense now? And then where are my little check marks? Okay. The circle is coming from the interval they give me. The check marks are coming from what I know about when it's positive and negative. Okay? You need them both. Are we good? Any questions? All right. So that's some just basic solving. Now let's look at some factoring. Okay. Just because there's trig in there does not mean that it's more difficult, okay? It is the same kind of factoring you've been doing like forever. When you look at number 7, you have 2 terms. Do those 2 terms have anything in common? Sine, right? Sine theta. So can I factor it out? I can factor out the GCF, right? So I'm going to factor out a sine theta. That leaves me with sine theta, what? Plus 1, and that all equals 0. So just like if this was x times x plus 1, it is factored, yes? So it is factored now. Now that you have it factored, you set each factor equal to what? 0. So that means I'm going to set sine theta equal to 0, and I'm going to set sine theta plus 1 equal to 0. That means here theta is equal to the sine inverse of 0. And here, this would give me sine theta equals negative 1. So theta equals the sine inverse of negative 1. Okay. So you have 2 separate things going on here at this point. Everybody with me? Now, the interval is just 0 to 2 pi for all of them. So it's just the whole circle. So this is just 0, which is going to be a quadrantal. This is actually a quadrantal also, so it doesn't, it's the whole circle, so the quadrants don't even matter since they're all quadrantals anyway. But here, I'm getting that theta is equal to, when is sine 0? Or what's the sine inverse of 0? 0. The sine inverse of 0 is 0. And then sine is also 0 where? At pi, because if it's a 0, it's going to have to be at pi, right? And then where else? 2 pi. And we do count that because the whole interval goes from 0 to 2 pi. So even though it like happens twice, it technically happens 3 times because you go back to where you started from. When is sine negative 1? 3 pi halves, okay? So once you get the answers from the 2 separate pieces that you have, you put them all together and you put them in order from least to greatest. So this would give me that theta is actually equal to 0, pi, 3 pi halves, and 2 pi. There are my 4 answers. Okay, everybody good with all that? Any questions at all? All right, let's look at number 8. What can I do in number 8 to start to solve it? Factor out cosine. Good. So this is going to give me cosine theta times tangent theta plus 1 equals 0. I have it factored. I can set each factor equal to 0. So cosine theta equals 0. And if tangent theta plus 1 equals 0, then tangent theta equals negative 1. You okay? Jump into that step? Yeah. Stop me if you don't know where I got that from, but you can kind of leave out that part. So theta is equal to the cosine inverse of 0, and theta is equal to the tangent inverse of negative 1. So again, the whole circle is what we're looking for. Cosine inverse of 0 is going to be a quadrantal, so I'm not so worried about those quadrants, but this one is not. So the quadrants where tangent is negative is going to be the second and the fourth. Does that make sense? I'd need 2 separate little check things for each one of them, but the first one doesn't count because it's quadrantal. When is cosine 0? Pi halves. And when else? 3 pi halves. Good. And then, so the tangent inverse of 1 is what? Pi fourths. But I actually need the second and fourth quadrant angles of that. So what's my second quadrant? 3 pi fourths. And then my fourth quadrant is 7 pi fourths. So there's my two sets of answers that I then put together to make them from greatest to, or I'm sorry, least to greatest. Gives me, so I start with pi halves, and then 3 pi fourths, and then 3 pi halves, and then 7 pi fourths. And it shouldn't be a real strain on your brain to get them from least to greatest because you can think about where they are in the circle. All right. Yeah, it's not that bad. Okay, so right here, I want you to, off to the side, we're going to take a little side note here. I'm going to give you the x squared plus 3x minus 4, and I just want you to factor that. So just factor this trinomial right here. Just factor it. Is that a pretty easy one to factor? Should be, yes. Come on, I started you off with an easy one. You know, this has to be x, and this has to be x, right? And then since this is negative, you don't have to solve it, just factor it. So the signs have to be opposite. And what is positive? 4, and this is 1. All right, so you can do that, right? Yes, no big deal. Now I want you to look at the x squared plus 3x minus 4 and look at what you have in number 9.
Oh, it's the same thing.
Do you see how they're the same thing? It's just that instead of x, you have sine theta. This is x squared plus 3x minus 4, right? It's the same thing. You factor it the same way, all right? You just treat them like x's. So when I go in here to factor this is a trinomial. The coefficient here is 1. So I'm going to do this. Instead of having x and x to begin, I'm going to have sine theta and sine theta. Because when I multiply them back, sine times sine is going to give me that sine squared. Does that make sense? Then this is negative, so the signs have to be opposite, plus and minus. And then I want it to be, they're going to have to multiply to give me a negative 4, but combine to give me a positive 3. So I'm going to need a positive 4 and a negative 1. And then if I multiply all that back together, I get that back. Okay, you see how it's the same? I wouldn't suggest changing it to x's every time. I'm just telling you, don't make it like it's something crazy hard just because it has trig stuff in it. It's the same simple factoring. None of these get crazy bad. So now that it's factored, I set each part equal to 0, which means here sine theta is equal to negative 4, and sine theta is equal to 1. So that means that theta is equal to the sine inverse of negative 4, and theta is equal to the sine inverse of 1. So what is the sine inverse of negative 4? It is not 1. Isn't it like... Can I take the sine inverse of negative 4? No, it doesn't exist, right? You can't take the sine inverse of anything less than negative 1 or greater than 1, right? Yeah. So the answer here, theta, is actually the empty set, and that's what the empty set looks like. It's like a 0 with a slash through it. And then, when is sine 1? Or what's the sine inverse of 1 is what I should have said. Pi halves, good. And so that means your answer then in the end is just pi halves. That's all we got. Everybody okay with that? All right.
So
Go ahead.
If they were both empty sets, then it would be...
That no solution, yeah. Or the empty set, yeah. All right, number 10. I want you to try and factor number 10 before we do it. Just factor it. You can do it. It's not that crazy bad. No, don't do the x. I just showed you that so it would be the same, but I wouldn't suggest changing it to x. You can think of it that way, but don't change it and change it back. Okay. Do we all have it at least factored? Okay. So I'm really glad none of y'all seemed frozen. Like sometimes you're like, I just don't even know what to write down. Because you should be able to at least start, right? You know that this should be cosine theta, and this should be cosine theta. And then since this is negative, these signs have to be opposite, right? They have to multiply to give you 3, so your only options are 1 and 3. You just got to decide which one you want to be bigger, and you want the negative one bigger, so this is your 3, this is your 1. Obviously, if you had the plus the second, that's fine. You know, the whole thing is switched around. So we got this. Are we all good with that? Factoring's no big deal? Good deal. So then we get cosine theta equals -1, and cosine theta equals 3. So theta equals the cosine inverse of -1, and theta, I keep writing this wrong thing. And then theta equals the cosine inverse of 3. Okay, we all good so far? All right, I'm going from 0 to 2 pi, so it's the whole circle. When is cosine, or what's the cosine inverse of -1? Pi. So theta is equal to pi. That's the only time you get a -1, right? What's the cosine inverse of 3? Empty set. That means your only answer is pi. Okay, we good? Look at that. Y'all factor in trig equations. It's a breeze. All right, any questions? All right, let's look at number 11. Is that a difference of squares? Can you, is this first term a perfect square? Yes. Is this a perfect square? Yes, it is. And then it's minus, so it is a difference of squares. It's the same thing as if we had, you know, x squared minus 9, like that. That's x plus 3x minus 3, right? X plus 3, x minus 3. Yes? Difference of squares? Easy? So all you do is take the square root of the first term, the square root of the last term, and you're done. So I can factor this. Right? It just becomes 2 cosine theta plus 1 and 2 cosine theta minus 1. It's a difference of squares. You got to be able to recognize them in both directions so that it's easier for you to multiply. Like when you're multiplying back together, if you don't notice it, I mean, it still just works out. You're just kind of wasting your time. But this definitely does make this factoring easy. So now I set each one of them equal to 0, which means that cosine theta is equal to -1/2, and cosine theta equals 1/2. So it just means I want all of the angles that would give me that, you know, that 1/2. But what's the cosine inverse of 1/2? Remember how to do that with your hand trick? This is cosine's 1/2, so that is pi thirds, right? So theta is going to be pi thirds. And then cosine's also positive in the fourth quadrant, so that would give me what? What's my fourth quadrant pi thirds angle? 5 pi thirds. 5 pi thirds. Okay, and then my second and third quadrant ones are the negative ones, so my second quadrant angle would be, for pi thirds, 2 pi thirds, and then 4 pi thirds. And since you wanted all 4 of them anyway, if you just from the beginning put them all in order, it's fine. I don't want a comma there. It's going to be pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Everybody okay with that? Any questions? All right. Now look at number 12. We have a trinomial. A is not 1, and I don't have a GCF to factor out. Okay. How would you normally factor something like this? You can A times C, and then do you do grouping? Is that kind of your go-to way to do it? There's a divide and slide thing that I'm not a big fan of, but yeah, I don't know if any of y'all taught it, but it's not really. It's because people usually forget the last step and then just get it wrong every time. So grouping is fine. You know, multiplying and then separating and grouping, nothing wrong with that at all. However, if A is not 1, but it's a prime number, you should be able to kind of reason through it to make it easier on yourself. That's something as big boys and girls we got to kind of learn to do without having to go through the exact same steps every time. If this was not a prime number, then grouping might be the best way to do it so you don't have to guess and check quite so much. But here's what I know when I factor this. So I want to kind of talk you through this, but if you have to in the end do grouping, it's absolutely fine. I know that if it factors, I'm going to get two binomials, right? So I'm going to go ahead and write this out. Instead of it being sine and sine, it's going to have to be 2 sine theta and sine theta. Okay, and at every step you can check yourself, because 2 sine theta times sine theta would give me 2 sine theta squared. We agree with that? Then I can look at the signs here. This is negative, so they have to be opposite. But you can't just plop them down this time since these are different. You're not necessarily sure which one it goes with. But it's nice when this is 1, because that means these two numbers here, no matter what, have to be 1 and 1, right? That's your only option. So that, because the last two have to multiply to give you this. So then you have to figure out the signs here. In the middle, you want a positive sine theta. So if I put the plus sign here, when I do my little FOIL, this would give me a positive sine theta and a negative 2 sine theta, which would give me a negative sine theta, right? So I don't want that. I want the positive here and the negative here. And then you check yourself. This is the key. That's the key to the divide and slide too. Nobody checks themselves and then they're just wrong. 2 sine times sine is 2 sine squared. Negative 1 times positive 1 is a negative 1. This is a negative sine theta and a positive 2 sine theta. When I combine those, I get that positive sine theta there. Does that make sense to you? Or did I just lose you and do we need to do grouping?
No, I think, can you show us one more time that?
Yeah. It's been a while. Well, I'm not sure that, because this is kind of the guess and check way. This is actually like how I was taught to factor. Like there was no tricks or anything. It was like you just had to know and reason through it. I don't know that you're shown this a whole lot just because it is kind of a guess and check thing where the grouping just works every time. Like it's just a process. But yes, I'll talk you through it again. Talk you through how to put them in there or how to check yourself. Okay, so when I multiply these two, it should give me the first term. So, and then it does, right? I multiply these two, it gives me the last term. Okay, now that doesn't always guarantee that I'm 100% right, but I'm on the right track here. When I multiply the inside two, this gives me a negative sine theta, right? And then here, when I multiply the outside two, I get a positive 2 sine theta. Well, when I combine those, that gives me a positive sine theta, which is that term right there. Okay, so that's kind of how to check yourself. If you need to do by grouping, do you know what I mean by that? Tell me if no, if I need to show you. Like you're going to do, because with the trig, it might look a little funky, so I'll do it over here. 2 times 1, that's your negative 2, right? And so they've got to multiply to give you 1, but combine to give, multiply to give you negative 2, but combine to give you that positive 1. So you'd get 2 sine squared theta, and then you'd have plus 2 sine theta minus sine theta, and then minus 1. And then you do your factoring by grouping. Okay? But that, so then I would, factor out this 2 sine theta. That leaves me with, what? Sine theta plus 1. And then here I factor out a negative 1, and that leaves me with sine theta plus 1. And then that gives me 2 sine theta minus 1 times sine theta plus 1. That's your grouping. That's a whole lot of work to me when you can kind of reason through it, okay? But you got to understand the reasoning through it to be able to get there, okay? Everybody okay with that? So now that we have it factored, we can set them equal to 0, which means here I get sine theta equals 1/2, and sine theta equals negative 1. All right, so I want sine to be positive and negative here, right? So the positive sign is going to give me quadrants 1 and 2. And so that means here that theta, what's the sine inverse of 1/2? Pi 6, right? So I do want quadrant 1, so it's pi 6, and then my second quadrant pi 6 angle, which is what? 5 pi 6. Now this is negative, but it is quadrantal, so it doesn't really, matter what quadrant we're talking about. When is sine negative 1? 3 pi halves. So theta is equal to 3 pi halves. And then I just put them in order. Theta is equal to pi 6, 5 pi 6, and 3 pi halves. Okay. Questions? So I'm going to give you a minute, and I want you to factor number 13. You can factor it by trying to reason through it. You can factor it by grouping, whatever, but you got to be able to get it factored. I know you can factor stuff like this. Don't freak out because it's trig. Just pretend like they're x's and everything is fine. Okay? I'm going to give you a minute to do that. Okay. So here we go. So the first thing we would need to do here is to subtract this 3. So 2 cosine squared theta minus 5 cosine theta minus 3 equals 0. So I know some of you did grouping, and that's absolutely fine, but I'm going to kind of talk you through this. I know because this is a prime number, this is good. This is 2 cosine theta, and then this would have to be cosine theta. Now, the numbers that go here and here have to be 1 and 3. That is my only option. So it's nice when this is a prime number too. So 1 and 3, and the signs have to be different. So I can start by just kind of putting something in there and seeing what happens. Maybe I'll put my 3 here and my 1 here. When I do that, I get a 2 and a 3. If I combined them and added them, I could get 5, but the signs have to be different, so it's not going to work. Instead, I have to scream over this. If I put my 3 here and my 1 here, since I want my signs to be opposite and I need the bigger one to be negative, to be a -6 and a +1, that gives me the -5. Okay? So that means that cosine theta is -1/2. Cosine theta equals 3.
Also, congratulations to Maverick Color Guard on the performance this weekend at the TCGC Area South Championships. Color Guard placed 3rd in their class and advanced to the TCGC State Championships this coming weekend in College Station. Also,
so we know that this gives us the empty set, right?
They competed at the Morton Ranch show this past week.
-1/2. Cosine. Cosine's a negative here and here. Cosine inverse of 1/2 is pi thirds. So we get 2 pi thirds and 4 pi thirds. There you go. Got it? All right, good deal.